Once you have completed your reaction in the Erlenmeyer flask and you have poured your material in the separatory funnel, you will then use various salts to work up and extract out your organic layer in a shell vial. You can label this first shell vial as V1. Once you have your V1, which you do not need to pre-weigh, you will tilt your shell vial. So you can better see if there is any aqueous layer left behind. You will pipette this layer out and discard it or put it in the aqueous beaker that you already had. If you're using an Erlenmeyer flask, then you will again tilt that Erlenmeyer flask, a smaller Erlenmeyer flask, to figure out if you have some aqueous material left or not. When you're adding sodium sulfate, remember, to each their own. You cannot figure out how much amount your colleague has added, and so how much amount you will add. You will have to keep on adding pinches and swirl the liquid so that you can observe if the fresh sodium sulfate particles, the white solid particles, are also swirling along with the motion of the liquid. After you have waited for 5 minutes, make sure you get a fresh pipette to collect the liquid only and not the clumps in a pre-weighed vial too. So you will need another vial to collect your material. Now there are two things that you have to do. You have to take the IR of this very product and in a separate vial. Please make note that you use a separate vial, not in a test tube. You will add 2 drops of this material and 1 drop of your AgNO3 solution. So this is a separate analysis. This is a separate analysis. When you will do the IR of your product, you will see that when you highlight the IR spectra, there will be 3 major regions where you will see any peaks: the OH, the sp3CH, and the CO. These are from your starting materials. So these are the bond types that we see on your product. Your starting material. Whereas for your product, the CO, the OH, and these 2 peaks are missing in this very product. So if you compare from here and compare in these 2 regions, these 2 regions are missing. All that you have for your product is the sp3CH bond type. So how do we confirm that you have actually synthesized an alkyl halide and not just an alkane? And this is where your AgNO3 test is going to help you. When you will have a drop of AgNO3 with 2 drops of your starting material, you will observe a colorless solution. However, as soon as you add AgNO3, a drop of AgNO3 with 2 drops of your product, the alkyl halide, you will immediately see some cloudiness or precipitation of white color, indicating that the material that you have added to AgNO3 is indeed an alkyl halide. So your IR confirms the absence of alcohol and your AgNO3 confirms the presence of an alkyl halide. Please note, some of you may see 1000 to 1300 peak in your product's IR, and that's fine, because if the OH is missing and you only have the 1000 to 1300 centimeter range, what does that indicate to you? This indicates that your alcohol is still there. But if your AgNO3 test with product is also colorless, then you will indicate that you have not formed the product at all. On the other hand, some of you may still have the 3600 to 3200 peak. This belongs to OH, which indicates that you might still have some water molecules left in your vial. But if you have both of these peaks present in your product also, then you definitely have your starting alcohol in the product. So you have to read your IR a little bit more carefully. When you start finishing up your data sheet, please make sure that you have recorded the numbers from your data sheet discussion document. Please pay attention to the calculations. These are very important calculations, and you need to remember to keep your significant figures also in the calculations.